Howdy, everybody in YouTube land. What we have in front of us today is a Texas Instruments color monitor. I've never seen one of these things. This was sent in to me for repair. I don't own any TI equipment, nor am I interested in it. It's just not my era of computing, but I will pretty much take on things to repair, and I'm kind of selective on what I bring in. So now this one, the complaint on this one is it works, but it doesn't work as good as it used to. The problem with that is that's arbitrary. I don't know what that actually means. So I've got to hook up a color bar pattern generator to it and figure out what that actually means, because not as good as it used to could be a faded CRT. It could be, dried out capacitors, or it could be the person's eyes. I mean, I don't know. I've got to see for myself what's going on with it. But, I mean, it's old. Could have capacitor related problems. Could have solder joint problems. It could have a lot of things. But upon first glance, we have a standard composite video input. It's a composite monitor. There's our chassis number, NMX-K6MC, which puts it quite squarely in the Matsushita or Panasonic. Model number is PHA4100. It's made in December of 1981, so it is old enough to start having capacitor problems. We've got all of our little controls down here. We have a drive, we have our screen controls, and all of that. Picture tube looks to be a Matsushita, so yeah, puts it still Matsushita territory. So, other than that, that's all I know. And it was definitely packed well, too. So, let me grab a color bar generator. We're just going to plug this thing straight in the wall because we know it works anyways. And see what, just do a quick observation what is going on with it, because I don't know yet. Alright, so pattern generator's hooked up. We're plugged in. Let's see what happens. Ooh. Pot needs cleaned for sure. I mean, it's hard to see on camera, but there's definitely a problem. Well, that's not right. As far as that's concerned, I don't know how this works. I think it just opens like that. Yeah. Let's see. We have brightness, tint, color. Let's see, tint. Oh, yeah. All the pots are shot. They need clean. There's your issue. Doesn't work as well as it used to. Well, yeah. How come I'm observing that? Also, this thing's loud. Brightness pot doesn't really work either. Let's see. Oh, God, yeah. Ooh, this is bad. This thing still gets really bright. So, the CRT is fine. I'll test it anyways, but... Alright. I don't like the way this thing sounds either. Listen to this thing. It's kind of screaming. It's like flyback screen. Oh, yeah. Just slamming the side of the case makes a huge difference too. It's hard to see on camera with the flickering, but... Oh yeah, this thing's got issues. Alright, well, at the bare minimum, we know we have potentiometer problems. And we have potential solder joint issues. So, we need to knock that out of the way first. But also, I want to take a quick look inside anyways, to see what kind of capacitors they are, because judging by the date code and who made the monitor, I have an itching suspicion that they used those purple Matsushita caps, and every single one of those purple caps have got to go. So, bare minimum, that's what we got. So, he was accurate that it doesn't work as good as it used to, because, yeah, we've got clearly age-related dirty potentiometers and possible bad solder joints. So, we need to just take a look at that and possibly resolve that first, and then check the monitor's performance and see how that works from that point. because that could all it really might be is that. But never know. So let's dig inside here a little bit more. I was able to get this thing apart, and the way this thing comes apart is rather interesting. The shroud comes off. There's a pile of screws in the shroud. But then there's a cover plate here that comes off too. Anyways, I do see some of the blue Panasonic caps, which I don't run into too much problems with most of the time. But I do see like these guys here in the orange or yellow jacket leak. And of course, we got our little blue purple ones down there. So they're going to have to go. But overall, looking at it, I mean, I'm not really seeing any solder joint problems outside of just a couple. There's one here that's cracked. There's like a couple over here, but otherwise it's not terrible. The worst of it is on the neck board. Like, for example, the blue cathode is completely cracked. You can see that. And then we got that solder joint, and I saw another one up here somewhere. I forget. Anyways, so the big thing of it is, it's basically, it just needs the routine age-related maintenance. It needs caps put in it. It needs all the solder work done to it, and needs all the potentiometers cleaned and worked. And that's probably it. It would likely all it would take to get this thing back into tip-top shape. I could test a picture tube just to see how healthy it is, because, you know, we have a pinout, so I can grab the CRT tester and actually test that tube. And you know what? Let's do that, because why not? We got a heater here. We got a heater red. We got the screen. We got cathode, ground. We got the grid, the main grid, and all of that. We've got everything we need to actually test this tube. So we could set that up. All right, so we should be wired up properly. We're going to check the red cathode first, do normal bias. I don't know, let's see, no shorts. I don't know what the filament voltage is for this. Don't know if it's 6.3 or if it's 12.6. The thing is, you can never tell with these picture tubes. I don't see any glowing. Let's see, 1, 2, 3, 4. So we have 1, 2, 3, 4, and 5. Oh yeah, that's the heater, supposedly. No gun balance. Alright, so let's go up at 8 volts. See if it's glowing. Let's go up to 9 volts. Go up to 10 or 12 volts. Yeah, I don't have any load. So no, that is not right. Not right at all. Oh yeah, there we go. That's why. G1 space heater. I think this is the red cathode. And then let's see, red cathode, then space, and I don't know. We'll find out. It's got to be you. The only thing I can think of is they got the grid internally connected to... Yeah, this doesn't make sense. The grid's either connected internally to one of the other elements, or it's connected to all these three. Because I have... Yeah, I've got a... this is crazy. There you go. I think we found it. So G2 is actually connected to or G1 I mean, is actually connected to the same one as these E potentials. It's ground. Actually, it's not even ground. Never mind, I thought that was ground. Nope. So yeah, this has G1, but it's going over here to E. E is, I don't know. Anyways, that's where it is. That's where our G1 is. So I got it. I was being stupid. Got it. So now we're going to check the emissions on the green cathode. So we got the gun balance set. Emissions, yeah, that still tests like a new picture tube. We're like way up here, almost to that red tick mark. So that one's strong. So we're going to move from green, cathode green, to cathode red, which is here. So we're going to do the same thing, set gun balance, slightly different. Still just as strong. We're good there. Okay, now we're going to check the blue cathode, which should be right here. Nope. That's not it. Maybe it's right there. Set the gun balance. Yeah, we're good. All three guns are well into the green. Let's do a life test. Oh, hell yeah. That's fine. Solid life test. Let's see how much power. Let's drop the development to 4 volts. Yeah, this thing is solid. Let's bring it down even more. Yeah. Nothing wrong with that tube. That tube still has lots of life left. Alright. After fiddling and fiddling and fiddling with this thing, because this doesn't really match what's going on here. I mean, it does, but also not really. So that's why it kind of threw me off for a loop. But how I generally do this, because this CRT tester is so old, it doesn't have any of the sockets for modern tubes. So what I did was I created this little black and white adapter, which is based off of the 10BP4, and that's my pinout. It would be easier if I had a label maker. I would just label these what they are. Cathode, filament, G1, G2, that kind of thing. But I don't have that. So anyways, the CRT is perfectly fine. So the next thing I want to do is actually get this chassis out of here so I can get a capacitor list together on that board. So that's what we're going to do next. It was a royal pain to get this thing apart. It's going to be even more fun to get it together. So I talked to the original owner to this thing. I think he said he's had this thing since it was new. But I asked him, I said, well, the CRT is in strong condition. It's worth putting work into. He wants to do a full, complete preventative maintenance service because of how old it is. And I don't blame him, because I would too. So we're going to get all new caps. We're going to get this all cleaned up and brushed up as best as we can. And we're going to move on from there. Now, one thing I did do is I figured out this monitor is actually a rebadged CT110M. And how I figured that out was this flyback transformer. If you look up the part number for the flyback transformer, it crosses over to the Panasonic CT110M broadcast video monitor. So that makes a lot of sense. That explains why the aperture grill, not aperture grill, but the shadow mask is the way it is, because it's kind of like a delta gun, but it's not, because it's kind of a very staggered phosphor. It's weird. But it's good. The CRT is good. And I think the CT110M I can actually pull a schematic for. I can't for this one. I can't find anything on this one, but I can get the 110M stuff, so that's good. What we're going to do, though, just for the sake of doing so, we're going to jot down the capacitor list, because it is full of these little purple ones that go bad. So they're all getting changed. And also, we got to clean out that stupid glue that gets hot, corrosive, and conductive and all of that too. So we got some work to do to this guy. Everything else, the rubber seems pliable. It feels like a silicone rubber, so it's going to remain pliable. Everything else looks to be good, and we know it works, other than the, bad potentiometers. But that's not surprising. So, all right, we're going to proceed with a full service. Step one, get the cap list off of this unit. And actually, I'm probably going to wash it first because it's nasty. It's driving me nuts. If I went looking for the service manual the first time around, I'd have figured this mess out really quickly, and I wouldn't have spun my wheels and looked like an idiot. But hey, we're here now. It's fine. It's fine. We got it. We got there in the end. We were able to test it, and well, here's the schematic to the monitor. So, and then that was it. Pin 2, what they have labeled E. What I do find fascinating though is this has a video and audio composite input, right? But notice this is a hot chassis set. It does not have a power transformer, and we all know you can't really wire a composite signal into a TV chassis that's hot unless there's an isolation transformer. So what they did was they've took an interesting approach here. So they've got a dead circuit and they have a live circuit. And what they did was they coupled the audio and video in through these isolation transformers on the signal side versus having a power transformer. It's definitely an interesting approach. I'll give them that. All of the capacitors have arrived, fortunately, and I have them all set out over here. So now a lot of this stuff is duplicates that I already have on hand, but some of it isn't. I ordered enough of them to basically redo this whole thing without needing to get into my own stash for the sake of, well, this is a customer. So we're just going to use all of those and get this done real quick. Well, I say real quick. It's probably going to take longer than that, but, Alright, so I just now started pulling capacitors out. I wanted to break in real quick and show this. So this is a blue cap. And I don't know if you can see this, but look at that. So not only are the purple caps known for going bad, so are those. Well, this thing absolutely needed capacitors, for sure. Anyways, let's carry on. Funny because almost all of those are doing that. Not all of them. Funny because the blue ones are doing it more than the purple ones are, but this one is especially bad. Look at that one. Yikes. Alright, so there's another thing I wanted to point out. These little .22s are just unobtainium. They're very hard to get in electrolytic format now. I can kind of get them in tantalum format, but I can also get them in film format. And I got both types because I didn't know if the pin spacing on the film caps would actually fit in here, and it looks like we're not gonna have any problems with that. And they also have the benefit of not being polar. So yeah, that fits in there perfect. That is perfect. So that will work out just fine. Well, I made a couple mistakes in the ordering process. So this is supposed to be 1,000 microfarad, and I'm missing that one, even though it says I marked it off. I don't know where it is. And then there's a 2200 at 25. Well, I've got a pair of 220s at 25. So I mistakenly forgot the 0 on that one. Ugh, dyslexia strikes again, I guess. I don't know. So that's an issue. So I got to dig in my stash and see if I even have a 2200. And then I know I got thousands, but still though, that sucks. I made a mistake. That capacitor looks bigger than it should be because I have it marked as 330 UF at 16 volt, but if you look carefully, 33 UF 16 volt, I said 330 F. So I mistakenly jotted that down as a 33 when it's really a 330. So I'm gonna have to go through my stash again and see if I have a 330 kicking around somewhere. I think I do. So all the capacitors are in now, including the correct 330 microfarad and this 2200. Now, the only one I had was a low impedance one, so I don't know if it's going to work in this circuit. It's a toss-up. Who knows? Anyways, I'm going through, double-checking everything. Looks like I have all the capacitors in there, so the next thing I'm going to do is flip this thing over and start working at the solder joints and just resoldering everything that could potentially be a problem, just to get it out of my way. So that's what I want to do next. Once I get that done, I'm going to spray out all of these potentiometers, the rear ones and the front ones. I'm kind of reluctant to mess with those, even though I should. But once I get that done, then we're going to start getting this thing put back together, I think, and then we can get it tested. Fresh caps are now installed. I went over this board just to make sure that there was no caps that I missed, because it's really easy to do. I suppose we're going to find out when we energize it, aren't we? Because it ain't going to work right. Had to fight with these. These were a pain to get back in here because I wanted this cable out of the way. Got the solder joints all taken care of. I even did the solder joints on the neck board because it was a problem. So, and then I got all the potentiometers sprayed out, at least on the main board anyway. So this thing is ready to be reinstalled. So hopefully everything works out according to plan. You know, we still have these film caps in here now we had to use as replacements for electrolytics. They should be okay. You never know. This appears to be the color burst circuit, so we're going to find out real shortly if we're going to have problems with that. Alright, so it's time to start getting this thing back together. Now, it's been a little bit of time, so I got to remember how to put this thing back together. Meanwhile, before I do that, though, I need the volume control power switch. I got to spray that out, and then we can start getting all these parts slid back in here. I just got to remember which ones of these screwed where and how, and, you know, that whole fun thing. loosely reassembled with basically everything put into place, we're going to fire this guy up and we're going to see what happens. So, here goes nothing. Ready? Well, we have a picture. Do we have anything else? Let's see. Turn the brightness down way bright. Well, I think these pots have had it. I cleaned them out, but turn the brightness down. Yeah, these pots are shot. Ola. Okay, there's you. We're going to do color. Tint. Yeah, these pots are gone. Should be, you know, it's kind of hard to tell because it's very not something like that. Pretty sure it's got to be closer to that. I think that's it right there. Okay, let's see. 75, 100%, yeah. A lot of tearing. So this thing has sync issues too. Let's see. Red field. Green field. Blue field. That's about right. It's not exactly the right. Red. Green. Blue. Yeah, I mean, it's about right. Let's see. 50% field, 100% field. There's not much of a difference there. Chroma response. Yeah, here's some. I don't know. It don't look right. So, convergence, not terrible. I mean, we've got some there, but other than that, convergence is really good. Steps. Fade. Let's see. Steps. So, the picture, a little too much green. The green has to come back just a hair. But we've got to get the brightness. Let's see. We need to bring the brightness. Yeah, these pots are shot. Bring the brightness down because it's way too... Is it performing any better than what it was before? Honestly, it's hard to say. We've definitely got sync issues. You know what? Let me change the impedance. There we go. That would do a lot. Oh, yeah, that made a huge difference. That made a huge difference. Turn the brightness. There, you stupid pots. See what it's doing? Pots are bad. Way too bright. So we're going to bring you down, up, somewhere like that. So we got you. Yeah, it's about right. That's where it needs to be. Color, bring you. That's too bright. Something like that. That right there looks really good. Looks really, really good. So, red, green, blue. Yeah, there we go. That's better. 50, 100. It's working fine. Chroma noise. Ah, yeah, much better. Much, much, much better. The impedance was wrong on the rear. Yeah, that looks right. That looks right. That looks right. That looks good. Yeah. This is our multi-burst. Looks good. That looks good. We do have some stability problems with the vertical output, and it's these shot pots. These pots are done. I'm just barely touching this pot. All right. Yeah, that looks right. All right, so what do we do from here? Well, the monitor is working properly. The issue, though, is these pots. I'm not sure what we're going to do about that. All right, so I'm waiting for the 4000 to start up, but I got my tuner hooked up into this thing because right now I don't have an easier way to get a video signal in there because I'm not set up for composite. I'm set up for RF. So I've got that connected to my antenna up there, and I'm receiving a signal into this thing. Makes a great little tuner. So just waiting for that system to come online so I can run a presentation and see how it looks. Oh God, holy overscan. We got to fix that. All right, so when I cleaned the height control, I put it back to its original position. So what I ended up doing was just rotating it back down quite a bit because remember, we have modern new capacitors which are much more efficient than the originals. So of course it was overscanned because we were getting a lot more deflection than what we had originally. So I had to back that down. I didn't want to take it too far down because this is for a TI computer and I don't know how much exposure this thing actually needs. So the other thing we need to do is now that we have that adjusted, I got to go back there and adjust the green down just a hair because we've got just a little too much green. Not a big deal. I can go in there and do that too. There we go. I brought the green down quite a bit. It only took a little nudge, but turn the color down, and yeah, that's about right. There's just the thing about a black and white image on a color tube, there needs to be a little bit more red to it and a little less green. So I got that adjusted, and that's right. That's accurate. We're getting what we need to be. God, these pots are shot. Even with spraying them out, they're done. They're worn out. So as far as color, that's too bright, that's too low. We need to be somewhere around there. That's about where we need to be, right there. So that looks amazing. I think we're doing really well with this thing now. So awesome. Awesome, awesome, awesome. It's got a really good picture. Really sharp. I think we're in the ballpark now. Yeah, those grays are really good. They're not overly green at all. They kind of were, so we're good now. I think we're cooking with fire, literally. Well, I hope not, but yeah, we're up and going now. No crazy smoke jobs, nothing like that. I think we're fine. I love it. I mean, other than the pots are shot, but you know, not a whole lot I can do about that. I can go back through there and spray them again, but honestly, I don't know if it's going to make a difference. And I've not seen that pot style before. So it's pretty special to this monitor. I tried to clean the potentiometers again, and they're only marginally better. The problem with the potentiometers is they're shot. They're just worn out. And the issue is those pots are pretty proprietary. I've never seen them before, and I can't find replacements. So they work fairly good as is. I'm going to leave them alone because I've crossed the point of you don't want to fiddle around too much because then there's the whole you want to leave well enough alone because I don't want to make them any worse than what they already are. The carbon tracks are probably just worn down, but anyways, it works fine as it is now and everything seems to be working great. I've let this thing run for a few hours and I've not had any problems. So we're going to pack this guy up and get it sent back to the original owner. We've got our bag of goodies right there that go along with it. Anyways, if you enjoyed this video, don't forget to hit the like and subscribe and all that fun stuff. Until next time, guys, thank you for watching.